Welcome to this explainer. Okay, if you write Python, you've probably hit that wall where your server is just buckling under the weight of concurrent users. You wrestle with threads, the overhead is a nightmare, and honestly, it just kind of feels like you're doing it wrong. Well, what if you are? Today, we're unlocking asynchrony. We're going to step into this mental model of a grand Victorian library, sit down with a senior engineer, and completely flip how we think about our server's time.
All right, let's just drop right into a classic developer nightmare. Picture a guy named Timothy. He builds a chess club server, and, well, he does too good of a job. Suddenly, 5,000 players hit his server all at once to check their rankings. 5,000. Timothy panics, right? He reaches for threads. But with 5,000 threads, his laptop literally sounds like a jet engine spinning up. So he pivots to processes. Bang, runs out of memory after just a couple dozen. He's totally stuck. I mean, how are you supposed to handle thousands of connections when you just don't have the compute power to watch every single one of them simultaneously?
Enter Margaret, his senior engineer. Now, instead of giving him some dry textbook lecture on OS architecture, she grabs 3 tennis balls and literally starts juggling right there in the office. And while keeping them perfectly in the air, she drops this absolute gem on him. She says, "You've been trying to hire 5,000 workers to stand around and wait. You don't need 5,000 workers. You need one grand juggler." Think about that for a second. Paying 5,000 workers just to wait for phone calls? That's unbelievably expensive.
And that right there is the whole philosophy of Asyncio. The old way, using thousands of threads or processes, it's basically trying to spin up parallel universes. It's massive overhead, but the Asyncio way doesn't do that at all. It uses a single event loop, one thread, one core, but you radically change how that core spends its time. When a task has to wait, say a database query or a network request, the grand juggler doesn't just freeze and stare at the wall. They toss that ball high into the air and instantly grab the next one.
Section 1. Translating the analogy to code.
So, how does this actually look in Python? Enter the coroutine. In our asynchronous world, the specific tasks our juggler is handling are these coroutines. You define them using async-def, and honestly, they look just like your regular everyday Python functions, but they have this almost magical superpower. They can be paused and resumed. They don't just run top to bottom and block the whole world. They're built to be interrupted gracefully.
But of course, a coroutine has to know exactly when it's supposed to pause. And that brings us to the real MVP of this explainer, the await keyword. Think of await as that literal split second the juggler tosses the tennis ball up. It's a yield point. When your code hits an await, it is explicitly telling Python, hey, I'm stuck waiting on the outside world right now, go do something else. That is exactly what frees up the juggler's hands to catch whatever task is coming next.
And to actually open the curtains and get this whole performance going? In modern Python, so version 3.7 and up, you just use asyncio.run. That's the standard trigger. It brings your grand juggler out on stage and fires up the event loop to start catching and throwing.
Now, I really want to slow down here for a second because this next part is the absolute secret sauce of Asyncio. When Timothy finally runs his new async code, he sees 3 separate tasks kick off, pause, and finish at the exact same time, 1 second total instead of 3. He's amazed, thinking, wow, this single thread did 3 things at once. But Margaret corrects him. She says, it didn't do them at once, it waited for them at once. The juggler is just switching tasks so incredibly fast during the downtime that it creates this flawless illusion of simultaneous execution. That's the trick. That's how a single server handles thousands of players.
Section 2, the specialist's warning, or rather, the juggler's biggest weakness. Because obviously once Timothy sees this magic, he immediately asks the million-dollar question. Can I use this for my super heavy grandmaster analysis math too? He wants to chuck these massive chess calculations right into the event loop.
And Margaret shuts that down instantly. Absolutely not. Think back to the hands of our juggler. If a task is heavy, like it needs continuous, intense CPU math, the juggler can't throw it in the air. There's no downtime. They have to hold that heavy ball and just stand there processing it. And while they're doing that math, the entire event loop stops. Every other task gets blocked. For Timothy's server, that means the ranking screens for every single other player out there would just instantly freeze.
Which brings us to Section 3, the concurrency toolbox.
As a Python dev, you have to know which tool to grab for the job. Margaret breaks it down perfectly. First, threads. Great for small I/O waits, but they cost you memory per thread. Next, processes. These are your heavy lifters, perfect for that intense CPU math we just talked about. but the cost, massive memory and CPU drain. And then Asyncio. It is absolutely unmatched for thousands of I/O waits, unbeatable. But the cost isn't RAM or CPU. The cost of Asyncio is entirely about discipline, your discipline. It requires strict, single-threaded discipline to work.
Section 4. Rules of the juggler. Because that discipline, it's totally non-negotiable. Async on cooperative multitasking. The system isn't micromanaging your tasks, it is trusting you to be a good citizen. You have to actively use await to give the juggler a chance to move on. And here is Margaret's final, most critical warning. Never ever use a standard time.sleep inside an async function. A normal time.sleep is what she calls a selfish sleep. It essentially tackles the juggler to the floor. The whole show stops for everyone. If you absolutely need to pause, you have to be cooperative. Always use await asynchrony.sleep. So that leaves us with a pretty important question for the next time you're digging into your codebase. Is your code being a good citizen? Are you effortlessly passing control back and forth to handle thousands of users, or are you sneaking in blocking functions, holding on to heavy tasks, and secretly tackling the grand juggler? Mastering async isn't just memorizing syntax. It's a complete shift in how you value your server's time. Keep those balls in the air, and I'll catch you in the next explainer.